Hi Ann, good morning. In this video, I am going to discuss Gauss divergence and Stokes theorem, one of the important topic in electromagnetic theory. So in the syllabus, we have a Gauss divergence and Stokes theorem. So what is Gauss law? Gauss divergence theorem. We all know it's something it related to the flux of vector field through a closed surface to the divergence of the vector field over the volume enclosed by the surface. That is called Gauss divergence theorem. So simply what in mathematical term what we expressed as triple three, that is triple integral, that is volume integral div a dv is equal to double integral a dot dA, that is the formula for Gauss divergence theorem. So in this theorem, that vector field A that is defined as a region of space, that is that is called as a vector field that is enclosed in the closed surface. So this is all about a Gauss divergence theorem. And I going to discuss the problem in Gauss divergence theorem. So first, what is the problem is evaluated both sides of the divergence theorem for a vector field. Here H is called as a vector field. They given and some vector field that is x, y, z, a, z, and they also define the limit 0, 1 for x and for y 1 to 2, that is 0 is minus x to plus x, that is 0 to 1. Here y, that is minus y to plus y, that is 1 to 2, and limit of z is minus 1 to 3. So here that is in triple one. What is the formula for Gauss divergence theorem? Triple integral div dot h dv is equal to double integral, that is in closed surface, h dot ds. So first we have to calculate the div dot h, that is div dot h is equal to dou by dou x. This is a general formula of divergence. Dou by dou x to x, that is in the given to xy, plus dou by dou y x square plus z square plus dou by dou z 2x again 2yz. This is 2yz. So we simplify, we get an 4y. So first we take a LHS, that is triple integral. So this is limit of z, y and x. 4y, that is the value dx dy dz. First we integrate with respect to x. Next we integrated with respect to y. Next we integrated with respect to z. So we all know the integration. So basic, here we not have any x term. So dx is common as x, 0 to 1 limit calculation. So here in this we have what we get is volume integral div dot h is equal to 24. We simplify this, we get the value 24. Then we take the LHS, that is a surface integral. So double integral h dot ds. So in this we have to classify it into 6 types, that is you take a cube as an example. So plus x to minus x, plus y to minus y, and minus z to plus z. So we have a 6 faces. So accordingly we classify this surface as ax minus ax, ay minus ay, az minus az. So we have to simplify the every term individually, we integrated, and finally we concluded the result. So here that is the limit for positive x, x equal to 1, for a negative side x equal to 0. That is for a negative side we indicated as a minus. Same for z, for y, that is 2 for plus side and 1 for minus side. So these are we taken from the limit only. So they in a problem, every problem they itself given the limit. So we taken the limit from the problem. So every time for every that is individual, we have to individually calculate the value. So here for then it's next one. So every individually we calculated. The final step is here. So h dot ds is equal to 12 minus 0 plus 3, 32 by 3 minus 32 by 3 plus 9 and plus etc. So what is the data? The final answer is 24. LHS is also same, RH is also same. So this is then hence proof this Gauss divergence theorem. This problem is belong to Gauss divergence theorem. We have to prove, or else they sometimes they ask the question, we have to calculate the surface. So by simply we calculate the volume integral, we also prove what is the value of the surface. By sometimes they ask that by using Gauss divergence theorem. So accordingly we can answer. Next application of Gauss divergence theorem, Coulomb's law, inverse square law force in superposition, linear superposition of the force due to all charges. That is an all example application for Gauss divergence theorem. Next one is Stokes theorem. Stokes theorem is a vector field, that is this theorem is a it is a vector field along a closed curve to its behavior on the surface bounded by that curve. So it is actually what is the statement is the circulation of the vector field around the curve is equal to the flux of the curl of vector field through the surface. That is the statement. So this theorem, Stokes theorem, we generally call as a Stokes theorem, is a powerful tool in analyzing the behavior of vector field in three-dimensional space. So in electromagnetism, we use this theorem that is related the circulation. This is an application, we can say that where we apply this Stokes theorem, where it is related with the circulation of magnetic field around a closed loop of the surface integral. That is an electric field. Particularly, one can understand the electromagnetism and magnetic flux. Sometimes this theorem is a key tool for mathematical analysis, particularly in the study of differential equation, vector calculus. We can use this theorem. It is very good to understand that theorem. And sometimes it is enable the conversion of surface integral into a line integral or vice versa. Accordingly, that is actually a bridge between a differential mathematics and facilitating the calculation. So this is all about a Stokes theorem, and also we discuss a problem in Stokes theorem. So first problem is just I not what we see in the Gauss theorem. I not ask a proof, just to evaluate the Stokes theorem. So here I given a problem x by dx plus x square dy. So here the limit can be x equal to 1 to minus 1, y equal to 1 to minus 1. So we have to evaluate this, and what we calculated is using the Stokes theorem, we have to evaluate the single integral. So that is integration of f dot dr is equal to double integration curl of vector field dot ns. So it is very easy to calculate the surface integral. So we take the RHS. So before that, div cross f, we have to calculate what is the value is y square minus x. By simply calculating this by using the surface, because it is in only one surface dx dy. So what we calculate by simply integrated the term, and what the value is 4 by 3. This is the answer for this problem. Thank you.